Some of the common questions that comes in mind are: why is the sky blue while the clouds aren't? Why is the sun yellow and why does it turn reddish orange during the sunset and the sunrise? These questions might be difficult to answer at first, but the physics behind them is not difficult at all. There are two things that play an important role in giving the color to the sky. One is the atmosphere of the earth and other is the sunlight, of course. So we need to know more about these two first. The white light coming from the sun is a mixture of 7 primary colors, and each colored light has a corresponding frequency and a particular wavelength associated with it. The violet colored light has the shortest wavelength of them all, while the red has the largest wavelength. And what forms the Earth's atmosphere? The Earth's atmosphere is mainly composed of gases, dust particles, water droplets, and water vapors. Among the gases, the nitrogen is present in abundant quantity, around 78%. It is followed by the oxygen, which is about 21%, and the remaining gases are like of argon, carbon dioxide, and other gases which constitutes about 1%. Let's see what would happen when sunlight falls on these molecules. When sunlight strikes these molecules, it gets scattered. Scattering is a process in which air molecules absorb sunlight and re-emit it in various directions. However, not all the light is scattered equally. The amount of light that will be scattered is given by the Rayleigh's law of scattering. It states that the amount of scattered light or the intensity of scattered light is inversely proportional to the fourth power of a wavelength of a wave. I is inversely proportional to the lambda to the fourth power. If the value of lambda increases, then the intensity will be lower. If its value decreases, then the intensity of scattering will be more. Lesser the wavelength, more will be the scattering. So now I want to tell you among the 7 colors of light which will scatter the most. Yes, the light of the color corresponding to the smallest wavelength will be scattered the most. So blue, indigo and violet color will be scattered the most by these molecules of air. When this light travels to our eyes, the sky appears blue to us. But wait, the violet light has the smallest wavelength. Then why doesn't the sky appear violet or even indigo for that matter? It is true that the sky scatters violet light more than the blue light. However, why don't we see the violet sky? What's the reason? The following graph tells us that how much of a particular wavelength is emitted by the sun. Observe the graph well. As you can see, the sun emits more bluish and light bluish light as compared to the violet light, as more blue light is scattered by the air molecules, resulting in the blue color of the sky. And another reason that why we can't see the violet light is because that our eyes are more sensitive to the blue light than to the violet light. So this is about how the gases present in the air molecules scatter the light. Do dust particles and water droplets also scatter the light? Yes, they do. They scatter light as well. However, their size is much bigger than the size of the light waves, and hence they scatter all the colors of light in equal amount. So the white light that is entering the dust particles or even the clouds re-emits as white light again. That's the reason that cloud appears white. This is the last question that we need to answer, that why does the sun appear reddish during the sunsets or otherwise yellow? We will see that in the next video. Press the subscribe icon to remain attached with this channel.